Alright, hello students. We're going to be doing the lesson 15 practice problems. So again, do these by yourself and then come watch this video. If you haven't done it, if you haven't attempted these practice problems, do not watch this video yet. Go back and do the practice problems and then come and watch this video. So as we go through this, we're going to go and start actually looking at these, and you'll see me kind of toggle back and forth between this and this picture here. So this is what you've really gotten in your book. So it says problem number 1, 20 students participated in a psychology experiment which measured their heart rates in 2 different situations. And so you can see here you have it kind of flatlined. You have one little dot out here, one little dot out here, and this one's a little bit more spread out. Yes, it's a little bit more symmetric, but again, this is fairly symmetric as well. So if you look at these things, if you did the median or the mean on this, you would end up with pretty much the same result here on either one. So you're going to get, because of the symmetry here, you can just like look and say, okay, it's going to be about 87.5 for an average, a central tendency right about here. So you can get that with the mean or the median. And then you go down here and you have a nice bell-shaped curve here, and the mode also kind of comes into this one, but you can't really do a mode up here. So if you're going to compare these two, you can't really compare modes because it only works in one. And so mean and or median would work here, but I'll go with the mean on this one just because since it works in both, we'll just go with the mean. It's just a little bit more powerful. So you have about 87.5 here. You got an 85 as a mean right here. You see a really good symmetry. What's the appropriate, let me get my little picture out of the way here real quick. What's the appropriate measure of center, in other words, measure of central tendency, and variability? Use the data, explain your reasoning. Well, like I say, you can use mean, in which case you have to use standard deviation, or you can use median, in which case you use IQR. Each one will give you about the same result. One's not so much better than the other. Which situation shows greater variability? Well, if you look here, you got 75 to 100 on the extents, the minimum and maximum, versus 70 to 100. So this second one here, the situation B, is going to have a little bit more variability. So which situation shows greater variability? B does. Which situation shows a greater typical heart rate? Well, the typical heart rate would be 85 here and 87 point here. So situation A would show a greater typical heart rate. Right. And then moving on, number 2, invent 2 situations that you think would result in distributions with similar variability. Explain your reasoning. Invent 2 situations that you think would result in distributions of different variability. Explain your reasoning. Again, this is something that you can kind of populate through. If you have questions on this one, we can answer it in class sometime. But I'm going to let you kind of do that too, invent this stuff. See what you got. The data set and some summary statistics are listed. So you got a bunch of numbers that are depopulated here. They told you what the mean, the median, the standard deviation, the IQR is. How does adding 5 to each of the values in the data set impact the shape of the distribution? Well, if I was to drop a 5 in here, all right, what's it going to do to this data set? Well, you see this is fairly tightly compact here between 11, 12, 16, 17, 18, 19, 21. Well, a 5 is going to skew this thing to the left. And so if you do add the 5, then you're going to skew it. You're going to move the mean to the left. Right? It's going to go to a smaller number. The median is going to go and shift down maybe to the next number down once you add that. So the median will probably jog down 1. The standard deviation will become larger because you have more variability, and the IQR will probably go and move up a little bit too for the Q1 and the Q3. So that will probably go up a little bit. Does adding 5 to each of the values in the data set impact the measure of center? Yes. What will happen if you add 5 to each one, this whole data set moves over to the right. So you won't change the distribution, but you will add 5. The whole number system just jogs to the right. How does adding 5 to each of the values of the data set impact the shape of the distribution? Well, if I add 5 to each one of these, it's just going to simply make each one of these numbers larger, and so your mean would go up by 5. The median will still go up by 5. Your standard deviation unchanged. And the IQR, that'll just jog up 5 as well. So if you add 5, you move this entire numbering system to the right 5 units. The mean will go up by 5. The median will go up by 5. Nothing will happen to your standard deviation or IQR. Won't change it. And so we kind of went through all these. Adding 5 moves the data set up. So mean goes up by 5. Median will go up by 5. Standard deviations and IQR, nothing happens. You don't change the distribution. It still is just as variable as it was before. So does it ever change the shape of the distribution? Not really. I mean, it just moves that same bunch of dots over, and that's all it does. All right. Problem 4. Here are 2 box plots. Which box plot has greater variability? Well, if you want to compare variability, you look at the IQR. So you can look at these things and see that this one has a lot more variability just because the IQR is bigger. Now you'll notice that they have the exact same scale down here, so we can just eyeball this one. Less variability, more variability. Which box plot has a greater measure of variability? We talked about that. Which box plot has a greater median? Well, the median right here is about 105, that little center part, and this one is about, looks like about 103. So I'm thinking that this one has a greater median on it. All right. Problem 5. The depth of 2 lakes is measured at multiple spots. For the first lake, the mean depth is about 45. The standard deviation of 8 feet. The second lake, the mean depth is about 60, with a standard deviation of 27 feet. Notice as the second lake is generally deeper than the first lake. Do you agree with that? I would say that's a good way to say it, generally deeper, because the mean depth is 40 compared to 50, and since the variability here is just 8, but the standard deviation is 27 here, is more variable, but you know, this thing, it says it'll probably be a little bit bigger when you take 27 feet above and below 60. You'll get more variability. So I would say yes, just simply because the mean is higher and it has more variability associated with it. All right, problem 6. Dot plot displays the height, brown to the nearest foot of maple trees from 2 different tree farms. Compare the mean and standard deviation. All right. Well, it looks like the mean is the same. You got 3 dots here, 3 dots here. Standard deviation looks like you got all the way down to 4 and up to 12 in here, but this one's just between 6 and 10. So I'll say that the standard deviation is going to be larger on this second one, this second farm down here. Right. What does the standard deviation tell you about the trees in the farm? It tells you about the variability of the sizes. All right. And this second one is more variable. You'll have a bigger selection for heights that you want. Number 7, which box plot has an IQR of 10? Well, all you have to do is just go through the math on this one. So this looks like it goes from about, I'll say, 1.5 all the way up to about, looks like 12. This one goes from 9 to 12. This one goes from 2 to 12. So that one answers that question, which has an IQR of 10. That looks like that one, 2 to 10. And then this one is 6 to 9. All right, so this one doesn't meet. So only C really matches the question that they're asking here, an IQR of 10. What effect does eliminating the lowest value, -6, from the data set have on the mean and the median? So we take this little thing off. What's going to happen is now the mean, since you have this going away, this little, basically it's an outlier, you're going to see the mean move to the right more because you won't have the data being contaminated by this negative one. What's going to happen to the median? Well, if you look at this, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and with this one will be the 10th. So if you 1, 2, 3, 4, 5, right? So right between that 3 and the 5 is your original set's median. All right, but once you So your mean, or your median right now with the list that you have is set at somewhere between 3 and 5, so your median is 4. But once you get rid of this 6, now your median drops over to number 5. So it does move it up some, right? So both your mean and median would move to the right if you were to get rid of the negative 6. All right? And that is all that we have on that one. All right? And let's see. All right, and so, yep, that's all we have for that. And we'll continue on with our next video.